All right, we are recording. So when you do work, again, treat it like you're training to be a professional and you want to do nice work. So when someone looks at your page, what is this? Well, label it. So label things, date things if you need to. I'm going to do this example. I won't take too much time. It will be chapter 1, number 5, part B. These should start getting quicker. You might be slow because you're overthinking them, or you're thinking that you have to do a calculation. You don't. First thing that you do in a problem is do a quick read. So get a sense. Don't try to hold on to everything. Just get kind of a sense. This is Julia takes a strobe sequence of a pelican flying down. So I'm going to assume that you did that. You can pause. And then you've read the quick read. And now we read through it again. We pull that information out. Before we do any calculations, we get lost in the calculations. So here we go. Let's see. Pelicans flying straight down to the water to catch fish. The pelican starts at 20 meters and flies at a constant 65 kilometers per hour. Do not calculate anything, etc. Show a complete sketch of the bird at 0.2. So let's do that. I'm going to label all kinds of things. There's 5 parts. So the bird, don't draw a crazy, complicated bird. I'm going to remind you of something though, real quick. So what we're doing here is describing motion. And the reminder here is that when you're describing motion, we deal with time, some earlier time, some later time, and some change in time between earlier to later. We deal with position, some earlier position, some later position, and some, oops, hello. See, make a mistake, always checking back. Change in position called what? What do we call change in position? Anybody? Oh, no one's here. Displacement. And then we've got, of course, velocity. What color should velocity be? Velocity. And we can have a velocity earlier, velocity later. We can have a change of velocity, but we're not going there right now so much. We will. And of course, there's acceleration, which we will try this purple pen out and see what acceleration. Often, oh no, we won't. Black that. So often for acceleration, now I'm going to use orange. It will often be either 0 or constant to begin with. That's describing motion. That's what we need to label. So we know that off the bat. Let's see this specific case. We've got a bird flying over the water. So let me draw some water. There. And a pelican. So I'll make the pelican. And I'll start it up. Can you see this? Sorry about the reflection. You can see the dome of our planetarium in that reflection. And so I'm going to draw it as a square. Don't take too long. We want to get this done. Okay. And that's going to be my first state or instant where I pause. There's a movie here, and I'm going to pause it. And so I'm going to I'm going to label that. Let's see, flies. And it starts at a position at 20 meters and flies the constant straight down to the water. It starts at 20 meters. So then what does that mean? And it's not that clear. And occasionally I'll do that so that you go, well, that could mean this or that. And so you can look at the solutions or you can ask a question, right? So let's do this. I'm going to go up here and I'm just going to show that from here to here is 20 meters. We'll get more picky about significant figures in chapter 2 and things like that. Okay. And flies at constant 65 kilometers per hour. So I'm getting this written down. Oh, wait, let me see part A. So you see how I'm doing this? I'm kind of bouncing around a little bit. And just like a puzzle, doesn't matter which piece you grab, just start sorting the pieces out. So I'm just grabbing. Part A says show and label your choice for the coordinates. So I know the bird's flying down. I'm going to choose down to be positive. And we often use vertical Y for position. We could use X, doesn't matter. So I'm going to choose this. Now you could choose up to be positive. If you're consistent, that's fine. I'm going to call it plus Y. There, I've shown my coordinates. Now I won't get messed up. If there's something going up, that's negative. Down, positive. All right, cool. Show and label your choice for coordinate direction. That's part A. I'm already done. Show and label positions and those variables. Just put in the variables. We'll need to calculate later. Okay, cool. Positions. All right, I need the positions. So there's one. You could put one next to it or just one inside of it. It's going to fly down. And I'm not sure how far. 2. Now I do know. So you got to read back because you can't catch it all. Go back 20 meters, flies at a constant speed. What else is in there? Julia takes a strobe sequence of photos. Oh, so you'll miss this first. We're going to. I do. We all miss stuff. We go back. Strobe means that there's the same amount of time between each picture. Now that means if you go faster and faster, you're going to go farther and farther. If you're going slower and slower, you're going to first go far and then you go less to slower and slower. If you go the same speed, you're going to go in the same amount of displacement for the same amount of time. Okay, so that means I'm going to draw that kind of like that one. Now, there are times when you don't pick up something and you draw something wrong. So expect that. Expect to make a mistake. Oh, yeah, wait. You're moving the pieces around. That piece doesn't go there. I got times 0, 0.2, 0.4, 0.6. So time state number 4. And so I want to show and label the positions. Okay, so position I made blue. You don't have to color code, but I can go X1, X2, X3, X4. That's all I mean, right? Now, where is X equal to 0? I don't know, wherever you want. We'll see if I get asked that, or we'll talk about that. Cool. That's part B. That's it. C, show and label displacements and those variables for states 1 to 2, 1 to 3, 2 to 3, and 2 to 4. We're just going to put in the sub. So I want the displacements for 1 to 2. That means it goes from here to here. Delta X 1 to 2. That's big enough on this screen. Maybe I should try writing a little bigger. See that. X1, X2, X3, X4, delta X 1 to 2, 1 arrow 2. There's that one. And then what else did I say? I got to go back to it. 1 to 3. So that would be from here to here. Displacement or delta X 1 to 3. Did you notice something? I like to do this, so be alert. What did I do that's not consistent? By writing this out, you find things. Pencil's easy to erase, right? So is whiteboard. I did Y for coordinates, but I used X here. So when you're doing that, be aware. Are you using X or Y? What's your choice? And so when I do this, I go, wait a minute, and you catch it. And so you can make a Y out of an X pretty easily, right? Look at that. Ooh. Our whiteboard. Oh, yes. Yes. Okay. And you could have used X, but vertical, we often use Y. Just nothing magical about that. 1 to 3, 2 to 3. That would be from here to here. Delta Y 2 to 3. And finally, 2 to 4. That would be from here to here. Delta y 2 to 4. Okay. So if I do calculations, I'll know it's too much to keep track of. And I can see it. And I can also see in here, my y is a little more y-like. I can see in here real easily that these are all in the direction that I called positive. You might have called up positive, then these would all be negative. So when I calculate, I better get positives because otherwise it would not make sense. That's what we're doing here. And if you can get quick at it, good. All right. So I did part C already. D, show and label velocity variables with subscripts and values at every state. All right, so that's what it says. I used green. Okay, fine. Green. I've got V1. So it's going down. Now do not do this. There is a book, at least one, that goes from there to there and says V1. It's not right. Not right at all. There wasn't a purpose, but it was. So I'm just going to go like this. V1. Now I know that V1 is, did I remember it correctly, 65 kilometers per hour. Fine. Yes, I did. And then it's going to be the same. We call it a constant velocity, same speed, same direction. And at that constant velocity, I'm also going to have V2. Now watch how I could do this. V3. So notice I keep that length about the same. So you can see if someone's careful, they either don't know yet in the problem and you calculate it, or they're actually aware that the speed is the same. Now over here, I could put V1 equals V2 equals V3 equals V4 equals 65 kilometers per hour. I want to keep track. This is my puzzle and I want to keep things organized. Sorry about that glare, right? So we've got that. You can always pause. But make sure you're thinking this through because watching is not the same as taking a new problem. That's where your brain gets wired. And E, don't forget to write what you know about the acceleration, right? So we've got that acceleration. I've got my positions, my displacements. I've chosen, I didn't do early and later. I put in specific numbers. I've got velocities, acceleration. Well, I know that if it's saying the same direction and the same speed, that the acceleration the entire time is 0. If it's increasing speed, the acceleration is in the direction of velocity. It's decreasing speed, the acceleration is opposite. Those can be plus or minus depending on the direction. Finally, I didn't ask you for some reason to put in the times, and you could put that. I mean, I gave it to you. I guess T1 is equal to 0. T2 is equal to 0.2 seconds. T3 is 0.4 seconds. T4 is 0.6 seconds. If I remembered correctly, I go back and check. So you see, you're always going back and forth checking these things. Now I'm laid out. Now when I do a calculation and I get a negative sign when it should be positive or vice versa, or when I'm asked for different things, I can look at it and go, oh, that makes sense. Now I understand the physics of it, right? So may the F equals M, this is acceleration, be with you. Really, it should be force. This is a force. This is not a force. You'll see that in chapter 3 or 4. I mean, excuse me, 7 or 8. All right, cool. Keeping it short. That's it. Go do the other ones. Just do them kind of quickly. Get in the groove until you're doing this fast. We're going to build up a little more complexity. You'll be in great shape.